Okay, our lesson for today is multiplication comparisons. And in this lesson, we're going to use multiplication to describe some of the comparisons that we're going to be making. So hence the multiplication comparisons. So let's look at this problem right here. This problem says Tara has 3 times as many soccer medals as Greg. Greg has 4 soccer medals. How many soccer medals does Tara have? So in this problem, we're really looking at these two people. So Tara and Greg. So let's write that first. So Tara and Greg. Okay, so in the problem, it says that Greg has 4 medals. So let's give Greg some 4 medals so we can see those. We'll just do them as stars, I guess. That's good. There's 1. 2, 3, 4. Okay, so in the problem, Greg has 4 soccer medals. Before it says Tara has 3 times as many. So really what we're looking at is we're trying to compare these two using multiplication. So watch how we do this work. This counts as one group of 4. So what Tara's going to have, Tara's is going to have 3 times as many as this group. So let's give her 3 of those groups. So Greg has one of those groups and Tara has 3 times as many. Let's think about how many stars or medals she has. So there's one group. There's one group. There's one group. Okay, so in this problem, Tara has 3 times as many as Greg. So another way you can kind of look at this is this is one group of 4. So that's 1 times 4. 1 group of 4. Tara has 3 groups of 4. Okay, so if you're looking at this one, Greg has 4 and Tara has 12. So I think for our first step is really to group these and draw models that go along with it. So it's really important to kind of do that step first, is to really look to see what the problem is asking and then kind of go from there using the information that's already there. So first step, draw a model. So here is another model of kind of what we just did, that Greg has this group and Tara has 3 times as many. So Tara will have 12 and Greg will have 4. So that's that first step. Okay, here is another problem that we can look at that has kind of the same kind of features, but in this case it kind of gives you the total. So this one says Angie has 36 coins. This is 4 times as many coins as Scott has. How many coins does Scott have? Okay, so this problem kind of looks at it a little bit different. So what we're going to do with this one is we'll show kind of like the same thing we do with subtraction and addition. We're going to use kind of a ribbon method to show how that works. So let's show it using the bars. So we have Angie has 36. So this box represents that there are 36 coins. This is 4 times as many as Scott. So what Scott has is actually 4 times less. So we can do, oh no, I don't like that one. Let's go with a rectangle. So what he has 4 of these, because it's 4 times as many. That's about right. 1, 2, 3, 4. So if we look at this one, we can see that there are 36 here. And 36 is 4 times as many as these. So it takes 4 of these to do it. So if we have 4 boxes, what number can we put inside of each box so that it equals 36? Or better yet, 4 groups of what equals 36? This is really what this problem is showing. It's showing 4 times blank equals 36. So we're trying to figure out this missing part, because we have the 4 groups, but we just don't know 4 groups of what is 36. So that's what we're looking for. So we can guess, we can do skip counting. If you know your multiplication tables really well, then you can look back at that. But I noticed that there's something here. 4 times something equals 36. 36, that's pretty close to 40. So 4 times 10, I know, is 40. This is a little bit less. So instead of 10, let me go with 9 right here. So that might be a good strategy, is to go up and then work backwards. So I know that 4 times 10 equals 40. And if I go back 1 group, then I'll get to 36. So I know that this problem right here is 9. So that's a good strategy to use. So let me do my 9. Okay, so let's see if that works. If I put 9 in these boxes, I can show my skip counting. There's 9, 18, 27, 36. So each one of these boxes is 1/4, or 4 times this equals 36. So how many coins does Scott have? Scott has 9 coins. That's how I can solve that problem, by using this ribbon diagram to help me. So that's a good strategy to use.